China's Tiangong, often referred to as the Heavenly Palace, stands as a pinnacle of space station technology, representing a remarkable advancement in human space exploration. Welcome to Spaceverse, your cosmic gateway to the wonders of space and interstellar exploration. Immerse yourself in a celestial journey with our captivating content, featuring in-depth essays and news updates covering the latest developments in the aerospace industry. From groundbreaking missions to the mysteries of the universe, we unravel the complexities of space exploration. Join us every week for cosmic insights, and don't forget to hit that subscribe button to stay connected with the infinite possibilities of the cosmos. Let's start. Despite its significance, Tiangong's recognition in the Western world is somewhat eclipsed by a limited understanding and awareness of this groundbreaking achievement. Departing from the conventional space station model, Tiangong exudes a futuristic aura, reminiscent of a creation from science fiction rather than adhering to established norms often likened to a submarine in space. The genesis of space station development dates back to the early 1970s with the Soviet Soyuz and NASA Skylab. Yet it was the Soviets' deployment of the modular Mir station in 1986 that set a new standard. Despite facing challenges, including the collapse of the Soviet Union, Mir's 7-module structure solidified Russia's leadership in space station innovation. The subsequent emergence of the International Space Station, or ISS, exhibits unmistakable similarities with Russia's Mir, representing a modernized version of its predecessor. However, a closer examination of the evolution in design from Soyuz to Skylab, Mir, and finally the ISS reveals a relatively incremental progression. Skylab, constructed half a century ago, stands out as an aesthetically pleasing outlier in this trajectory, as this journey of space station development is aptly termed, underscores the intriguing evolution of these extraterrestrial habitats. Tiangong's departure from the established norms adds a new chapter to the Spaceverse, challenging preconceived notions of space station design. Its futuristic aesthetics and technological advancements contribute to the ongoing narrative of human exploration beyond Earth. As Tiangong orbits above, it silently asserts its position as a symbol of China's prowess in space exploration, inviting the world to broaden its perspective on the ever-evolving Spaceverse. The stark divergence in design philosophies between the International Space Station, or ISS, and China's Tiangong underscores the dynamic evolution of space exploration. The ISS, bearing the imprint of Soviet design, mirrors the utilitarian aesthetics of a submarine, featuring confined spaces cluttered with exposed pipes and wires. This design, while functional, lacks the spacious allure associated with iconic science fiction spacecraft. In sharp contrast, China's Tiangong, developed just 2 decades later, signifies a leap forward in space station design. Comprising 3 modules forming a T-shaped configuration, Tiangong spans an impressive 55 meters in length and 39 meters in width, orbiting 400 kilometers above Earth's surface. The station's core command module, Tianhe, launched in April 2021, anchors the space station, while the Wentian and Mengtian modules, added in subsequent years, contribute to the station's multifunctional capabilities. What sets Tiangong apart is not only its futuristic layout, but also the remarkable speed of its construction. Unlike the ISS, which took a decade to reach completion, Tiangong's swift development is attributed to China's Project 921, initiated in the 90s. This project outlined a comprehensive blueprint for conquering space, beginning with the development of crew-capable rockets and spacecraft. The phased approach included milestones, such as the historic Shenzhou 5 mission in 2003, marking China's entry into low Earth orbit. Subsequent phases involved spacewalks, the deployment of miniature space station-like test modules, and the development of advanced spacecraft such as the Tianzhou cargo spacecraft and the Long March 7 rocket, introduced in 2016 as a modern replacement for its predecessor. In essence, the contrasting narratives of the ISS and Tiangong not only showcase technological advancements, but also reflect evolving philosophies guiding humanity's journey into the cosmos. The story of these space stations encapsulates the shift from the practicality of early space endeavors to the futuristic and expansive vision driving the latest achievements in space exploration. We find ourselves in the 3rd phase of a comprehensive plan, characterized by the ambitious development and construction of the Tiangong, aptly named the Heavenly Palace, signifying a significant stride in China's space exploration endeavors. The impetus behind China's unwavering commitment to establishing its own space station is rooted in a dual motivation. Firstly, there's an undeniable allure to having a personal hangout in space, a notion that resonates with the intrinsic fascination of exploring the cosmos. Secondly, and perhaps more significantly, the decision is fueled by China's exclusion from the International Space Station. The exclusion from the ISS traces back to 2011 when the United States, through a Department of Defense Act passed in Congress, mandated NASA to refrain from using its funding for any collaborative efforts with China in space exploration. The reasoning behind this exclusion was ostensibly framed around human rights concerns and national security issues. The U.S. cited apprehensions about potential intellectual property theft or espionage, reflecting a long-standing history of both nations engaging in covert activities. Faced with these stringent restrictions and the closed doors of international collaboration, China opted for an independent trajectory, adopting a resolute stance akin to hell with them, we'll build our own. This marked the genesis of the Tiangong space station, a venture propelled by China's determination to overcome external barriers and assert its capabilities in space exploration. The development of Tiangong not only represents a technological triumph, but also underscores China's resilience and self-reliance in the face of diplomatic challenges. As the Heavenly Palace takes shape in the vastness of space, it stands not only as a symbol of China's scientific and engineering prowess, but also as a testament to the nation's commitment to advancing humanity's understanding of the cosmos. The decision to forge ahead independently, in the face of exclusion, has positioned China as a formidable player in the ongoing narrative of space exploration, adding a new chapter to the unfolding story of human endeavors beyond Earth. Upon entering the Tiangong, one is immediately struck by its spacious and open interior design, offering a stark departure from the more confined spaces within the International Space Station or ISS. The Tiangong's interior embraces a minimalist and modern aesthetic, which, intriguingly, shares a similar outer diameter of about 4.2 meters or 14 feet with the ISS modules. However, the true distinction lies in the internal volume, where the Tiangong outshines its counterparts. In contrast to the ISS modules, which are often characterized by shorter lengths and numerous connection points, creating structural bottlenecks, the Tiangong's design prioritizes expansive interiors. For instance, the ISS's Destiny Lab, crucial for U.S. astronauts, measures 8.4 meters or 28 feet long. In contrast, both the Wentian and Mention modules on the Tiangong extend to an impressive 18 meters or 59 feet, offering a significant increase in available space for various activities and functionalities. Another noteworthy factor contributing to the Tiangong's spacious feel is the integration of modern technology. The Tiangong employs more compact and wireless technology, eliminating the need for intricate cable setups that are prevalent on the ISS. This not only enhances the overall aesthetics of the space station, but also streamlines functionality, providing a cleaner and more efficient operational environment. Additionally, the Tiangong's interior design incorporates a level of concealment not commonly observed on the ISS. Much of the technology on board is hidden behind plain white panels when not in use, presenting a clean and modern appearance. Whether this design choice is driven by considerations of functionality, aesthetics, or a deliberate effort to maintain secrecy about specific aspects of their work remains uncertain. This subtle interplay between design and potential strategic considerations adds an intriguing layer to the Tiangong's allure, as it not only embodies cutting-edge technology, but also reflects a deliberate and thoughtful approach to its overall presentation in the vacuum of space. In a significant milestone for China's space exploration efforts, the inaugural module of the Tiangong, named Tianhe or Harmony of the Heavens, successfully entered orbit in April 2021. Weighing an impressive 20 tons and boasting a maximum diameter of 4.2 meters. Tianhe serves as the comprehensive core structure of the space station. Designed to accommodate and support a crew of 3, this core module encompasses a range of essential components essential for the station's functionality, underscoring its pivotal role in the overall architecture of Tiangong. Tianhe's capabilities are diverse, incorporating solar panels to harness energy, propulsion systems for orbital maneuvers, life support systems to sustain crew members, a robotic arm for intricate operations, a sophisticated docking node, and an airlock for extravehicular activities. The core module is strategically designed with 3 main sections to optimize its functionality. At the smaller end of the core module, a spherical multi-docking node is situated, equipped with 4 ports, one of which is permanently attached to Tianhe. The opposite port on this node serves as the primary docking point for the station, facilitating the arrival and departure of the Shenzhou crew vehicle. Two side ports on the multi-docking node function as berthing ports for the twin research labs seamlessly connected to the core module. An additional port on the bottom of the node serves as a secondary crew docking point, crucial during crew handovers when 2 sets of 3 taikonauts may find themselves on the station simultaneously. The top port, while not designated as a docking point, serves a crucial purpose as a hatchway, enabling the crew to exit the station for spacewalks, an essential aspect of extravehicular activities in the vacuum of space. The strategic design of Tianhe reflects meticulous planning to ensure optimal functionality, versatility, and safety for crewed missions aboard the Tiangong space station. As China continues to make strides in space exploration, Tianhe stands as a testament to the nation's commitment to advancing the frontiers of human presence beyond Earth. Ascending to the slender cylindrical segment of Tianhe, we encounter the crew quarters, featuring individual bunks for 3 crew members and essential amenities, including a space toilet. Transitioning to the wider end of the core module, there's a workspace equipped with 3 experimental racks. This section also houses the propulsion unit responsible for maintaining orbital control. Lastly, there's an additional docking port at the module's end specifically designated for the Dianzhu cargo craft and earmarked as a future docking port for the Chinese Space Telescope. Tianhe is also the pivotal module supporting the station's primary robotic arm, measuring 10 meters in length, while slightly shorter than the 17-meter Kennedy arm 2 currently utilized at the ISS. The Chinese arm boasts comparable capabilities with potential for future expansion, a topic we'll delve into shortly. On July 24, 2022, China initiated the launch of its Wendian laboratory module for the Tiangong. Translating to Heavenly Quest, Wendian is another 20-ton structure propelled by the Long March 5B rocket, marking China's inaugural heavy-lift space launcher responsible for positioning the Tiangong modules into their 400 km high orbit. The Long March 5B configuration is noteworthy for its unique design, employing a hydrogen fuel-burning core stage and 4 liquid-fueled side boosters burning RP-1 kerosene. Ranked as the 3rd most powerful rocket globally, following the Falcon Heavy and Delta IV Heavy, the Long March 5B's method of placing 20-ton payloads into orbit has sparked controversy. Unlike typical rockets, after clearing Earth's atmosphere, the 4 side boosters detach, but the core booster engines propel the module to its orbital insertion point before separating. This unconventional approach leaves a significant portion of the rocket structure in orbit, avoiding an immediate descent into the ocean but lacking stability for a prolonged orbital presence. These objects are too substantial to disintegrate like standard satellites, and while they don't remain intact, fragments descend to Earth's surface. Consequently, the Long March 5B booster stage disintegrated over the Indian Ocean, showering debris over the Indonesian islands. The Wendian module serves a dual role on the space station, accommodating an additional 3 crew sleeping quarters, elevating the total station capacity to 6 occupants and providing space for diverse scientific experiments. Featuring 2 expansive solar panels with a 55-meter wingspan, the Wendian utilizes cutting-edge, ultra-thin, flexible solar cells for optimal surface area deployment, generating approximately 7 kilowatts of electricity. The module incorporates 4 experimental rack spaces focusing on life sciences, biotechnology, and variable gravity effects. At the smaller end, an area for external experiments allows the attachment of nodes for data collection, accessible by the crew through the airlock and hatch. Serving as the primary airlock for spacewalks, the Wendian's secondary robotic arm, measuring 5 meters, exhibits a unique crawling capability, moving around the station by grabbing and releasing attachment points, and can combine with the main arm to create a 15-meter robotic arm equivalent to the ISS's Kennedy arm 2 in size and functionality. The third and final crucial component is named Mengtian or Heavenly Dream. This research laboratory module joined the Tiangong in October 2022, resembling the Wendian but distinct in that Mengtian lacks crew sleeping quarters, providing more space for experimental racks. Additionally, Mengtian features its airlock, serving as a secondary cargo port, and boasts a large solar panel array identical to the Wendian. With the introduction of the 3rd module, the station is now fully operational and functioning at its maximum capacity. Regarding the Chinese Space Telescope, It is currently in development and anticipated to possess capabilities similar to the Hubble telescope. Operating independently from the Tiangong, it orbits nearby but is not physically attached to the station. The telescope is designed for docking with the Tiangong for convenient servicing and upgrades, a feature challenging with the Hubble and nearly impossible with James Webb, providing a significant advantage. Moreover, plans for expanding the Tiangong have been disclosed. Chinese officials, during a recent International Astronautical Congress meeting, unveiled intentions to enlarge the Tang station from 3 modules to 6. The plan includes launching a new multifunctional expansion module in the coming years, with expectations that additional full-size modules will join the station in approximately 4 years. Currently, the Tiangong is set to host a limited number of international research projects through collaboration with the United States Office for Outer Space Affairs and the European Space Agency, marking a positive beginning. However, due to the station's relatively small size, the presence of international crew members is unlikely for now, though potential expansion in the future could alter this scenario. Notably, Americans won't be involved with the Tiangong due to the reciprocal impact of the Wolf Amendment, mirroring the restrictions preventing Chinese visits to the ISS. While this information is challenging to obtain, it provides insights into the Tiangong's operations. Ideally, global political tensions will ease, fostering collaboration, but current circumstances, especially concerning Taiwan, suggest this may not happen soon. And that concludes our video for today. Thank you for joining us on this cosmic adventure through Spaceverse. If you enjoyed exploring the mysteries of the universe and staying updated on the latest in aerospace, don't forget to give this video a thumbs up and subscribe to our channel for more cosmic content. Your support fuels our mission to bring you exciting insights into the vastness of space. Keep reaching for the stars, and we'll see you in the next video.